Hi, this is Marwan, and today we will try to make the linear equations concept an easy concept for you through discussing the different forms of linear equations. Now, as you know, that linear equations is the basic part of heart of algebra that is allocated in any SAT test. And today we will be discussing the three different forms of linear equations, and that's slope-intercept form, point-slope form, and standard form. We will see how to be able to write them if we have a graph of a line and if we have 2 points that are allocated on the line. We are also going to explore how does the y-intercept and slope affect the behavior of the graph of the line. So let's look first at the three different forms of linear equations. Now we have the first form, which is slope-intercept form. And if we look at slope-intercept form here, you will see that y equals mx plus b, where m is the slope, and we discussed how to find the slope before in a previous video that I can link for you here, and you will find it on the end screen, and b, which is the y-intercept. Now actually I want to stop at the y-intercept and discuss what exactly it is. The y-intercept is the y-coordinate of the point of intersection between the line. Let's look at this line here, that red line. Its point of intersection was the y-axis. This is why they call it y-intercept. The point of intersection, as we can see, is 0 and 2. The y-intercept, or b here, refers to only the y-coordinate of that point, which is the value 2 in this case. Before we move further, I would like to explore with you how the y-intercept and slope affects the behavior of any line. We are going to pay a visit to Desmus graphing utility. This is a free graphing utility online. I am going to include the link for it in the description of this video. I really encourage you to explore it. You will be able through it to explore the transformation of all types of functions, and you can graph almost anything using that graphing utility just to help you study. Okay, so let's look at this line we have here, and as I said, I want to look at b. We said that b is the y-coordinate of the point of intersection between the line and the y-axis. In this case, it's 0. Let's see what happens if it increases. As you can see here, if it increases, the line will move upwards, and if it decreases, the line will move downwards. I just want you to see here that as the line moving upwards and downwards, how steep the line is does not change at all. Whatever affects the steepness of the line is always the slope. We discussed before that if the slope is positive, the line will have increasing behavior. As the value of x increases, the value of y will also increase. So let's look how it will behave. As you can see, if it's positive, it does have an increasing behavior, and it does, as the value of the slope increases, this line tends to approach being almost a vertical line. Now, going back, if the slope of the line is 0, and we discussed that before, the line is a horizontal line, and if the slope of the line is negative, like as we can see here, the line has a decreasing behavior. The value of y will decrease as the value of x increases. So we have seen here that changing the value of the slope does change the behavior of the line. However, it does not affect its y-intercept. The y-intercept shows the point of intersection between the line and the y-axis. Now that you have seen this, I really encourage you to pay it a visit, and let's go back to the different forms of the linear equations. Now we said that the slope-intercept form depends basically on the slope of the line and its y-intercept. Now we can easily find the slope of this line using the formula we discussed before, m equals y2 minus y1 over x2 minus x1. We can choose 2 points on the line. We already have one of them, which is 0 and 2. We can take another one, this one here, it's already drawn for us, which is 2 and negative 2. So this is our second point. We name them, as we said before, x1 y1 and x2 y2. I can say that the slope is equal to negative 2 minus 2 divided by 2 minus 0 which is negative 4 over 2. So I know that the slope of this line is negative 2. I already have the slope and I have the y-intercept, which is 2. I can write the equation of this line very easily. Y equals negative 2 as the slope, x plus 2 as the y-intercept. This is the equation for this line in slope-intercept form. Now the three forms will represent the same line, just looking in different ways. Like the three forms of the equation will represent the exact same line, but in three different ways. The point-slope form is one of the very most useful forms in case you don't have the y-intercept. Let's see, I can't see the y-intercept, or it's not accurate, it's somewhere between 2 points, like between 1 and 2. If it's somewhere here, you can't use it because it will not be accurate. In this case, it would be better for you if you use a point and the slope. You have y minus y1 equal m multiplied by x minus x1. x1 and y1 here are coordinates of a point. So let's choose any point we have on the line. Let's choose this point here, and this point has the coordinates of 3 and negative 4, as you can see. So this is a 3 here and at negative 4, and I'm going to choose this point to be my point. So the slope is exactly the same slope, which is negative 2. The point I'm going to use is 3 and negative 4. This is x1 and y1. It doesn't have to be the same one you used for the slope. It could be any point on the line. So the equation will be y minus negative 4 is equal to negative 2 multiplied by x minus 3. When you just simplify the two negative signs, it's going to be y plus 4 equal negative 2 multiplied by x minus 3. Now this equation here is an equation for the exact same line, but in a different form. The last form we will discuss is the standard form, and the standard form is one of the forms that does not include the slope in the form itself. However, we can find it using it. Like we have ax plus by is equal to c. All three numbers are integers. A and b are not equal to 0, and you can find the slope by dividing negative a over b. Now, how do I have to find it? You can't find it from the graph straight away. There is no values of a, b, and c you can substitute from the graph. However, you can find one of the other forms and change it into into standard form. So I'm going to use the slope-intercept form. We have y equal negative 2x plus 2. I'm going to use this form and change it into standard form by taking both x and y on the same side of the equation. If you add 2x to both sides, you will end up with 2x plus y equal to 2. So this form here of the equation is the equation for the same line, but in standard form. If you want to check, we said that the slope in this case is equal to negative a over b. A is the coefficient of x, so negative 2, and b is the coefficient of y, which is 1 in this case, so it is equal to negative 2, which is the same slope we have found from the start. So I have three different equations representing the exact same line. Why do we take all three types or three forms of linear equations? We take them so when you see a linear equation in any quiz or test or in any question, you can recognize that it's a linear equation. Now, the common feature between them, that all of them have two variables, x and y in this case, and it could be any other two variables, and that the degree of each of them, which is the power of each of them, is equal to 1. So x here is x to the power of 1. It's not x squared or anything, or to any other power. X here is the power of 1, and x here is the power of 1, and also the same for y. Now that we have seen the three forms of linear equations, we can find the equation of a line if we have 2 points on it. Actually, it's not going to be much different than what we did with the graph. This is going to be x1, y1, and this is x2, y2, and the first thing you're going to be looking at is how to find the slope. You have 1 minus negative 3 over 3 minus 2 is equal to negative 4 over 1, which is 4. Okay? Now, finding the slope is essential for us to find any of the equations. Now, we are required to find point slope form, slope-intercept form, and standard form of the equation of the line passing through these 2 points. However, we can't start with slope-intercept form this time because we don't have the y-intercept. But it would be very easy for you to start with the point slope form. So if I want to start with the point slope form, I know that it's y minus y1 equal to m multiplied by x minus x1, and I'm going to start substituting. Y minus negative 3 equals to 4 multiplied by x minus 2, and we can just simplify saying that y plus 3 equal to 4 multiplied by x minus 2. This is it, nothing else to do. Now, how am I going to find the slope-intercept form? I am going to use the point slope form to find the slope-intercept form. So I'm going to start with this equation. Now, how are we going to find it in slope-intercept form? Now, the slope-intercept form indicates that y should be equal to mx plus b, as we agreed before. So we can isolate y, so I have y on one side and everything else on the other side. I will get to that point. So I'm going to start with the point slope form and change it into slope-intercept form. First, of course, by distributive property. So you have y plus 3 is equal to 4x minus 8. Then I want y alone on this side. I'm going to subtract 3 from both sides of the equation, and you will end up with y equal 4x minus 11. So this is the equation of the line passing through these 2 points in point slope form. This is the equation of the same line passing through the same 2 points, but in slope-intercept form. My last one would be finding it in standard form, which should be ax plus by equals to c. And to find that, I'm going to start from the slope-intercept form. I have y equals 4x minus 11. I just want to have both variables with their coefficients on the same side of the equation, which means I want x to be with y on the same side of the equation. So let's subtract 4x from both sides. You will end up with negative 4x plus y equals negative 11. Now, usually, let's say you're solving an SAT question and you don't find that answer in the choices. Usually they tend to have a coefficient of x to be positive. So just divide all terms of the equation by negative 1. You will end up with 4x minus y equals to 11. So we have seen how to find the equation of a line passing through 2 points in all 3 different forms of the line. We saw how to change from one form to another. We explored how the y-intercept and the slope will affect the behavior of the line on a graph. And I think we know enough now about linear equations that we can, in our next video, explore how to solve SAT questions that are related to linear equations. I hope this has been helpful for you, and thank you so much for watching.